Okay. Okay, so this is just recapping over what we did today. So, so let's say we want to write a definite integral to represent the area underneath the graph of e to the 0.5t between 0 and 4, and then calculate the area. Well, writing the integral which represents the area is straightforward, right? 0 and 4 give us the bounds. E to the 0.5t gives us the integral that we have to, the function we have to integrate. That gives us there. So once we have that, then we know to use the fundamental theorem of calculus, right? What is its antiderivative? Well, it's an exponential. So we write down the function. The function doesn't change. The exponential doesn't change. The constant in front does, right? Because this is a 0.5. So we divide by 0.5, and so that gives us a 2. Then we evaluate it between 4 and 0, which is what we do here. Right, so it becomes 2 to the e squared minus 2, which is around 12.77. And here we get the representation of it right there. Okay, and we notice that this makes perfect sense, right? Because if we're looking here at a triangle of around height 6 and base 4, right, that triangle would have area 12. So that answer makes perfect sense. Fits in. So then we talked about improper integrals. Right, so an improper integral occurs if you try to evaluate it by the method before, you somehow get infinity involved or dividing by 0 or something. Something doesn't make sense. So sometimes it works and sometimes it doesn't. So here's another example where it works. We want to find this thing here, integral between 1 and infinity of 1 over x squared dx. So either this makes sense or it doesn't make sense. If it makes sense, then it's a convergent integral. If it doesn't make sense, it's a divergent integral, and we write, does not exist or infinite or something like that. Okay, so what we do, the way that we make sense of it, is instead of infinity, because remember, infinity is not really a number. Infinity is a behavior. It just means I'm putting really big numbers here. It's kind of like that game you used to play. I've got 100, no, I've got 101. Like whatever number you give, I can give a higher number when we're talking about it. Right, so the antiderivative of this, right? So if this is x to the minus 2, its antiderivative is, well, we add 1 to the power and we divide by it. So we get minus 1x between 1 and our number b, which is 1 minus 1 on b. Right, so if b is 10, then this area is 1 minus a tenth is 0.9. If this number is 100, then it's 1 minus 100, that's 1,000, it's 1 minus 1,000. So again, we see this idea of successive approximation, that we're settling in on a number. It stabilizes to an answer, and that answer is 1. So that means then that this area underneath this graph between 1 and infinity, that is 1. And so that makes kind of perfect sense because it's convergent. If we're getting numbers like, 1, 10, 100, 1,000, 10,000, etc. It's not stabilizing. The answer doesn't make sense. It's divergent. And we can't say that it's a definite number. Okay. What do you think this is going to be? E. Okay, so why can't it be A, B, or C? Because this is 6x squared, and we're just putting in, got 6x squared there. So we haven't done any antiderivatives at all. Okay, it can't be this. At first glance, the plus C thinks you, oh, it must be this, because we're integrating. That's only when you do an indefinite integral do you need the plus C. When it's a definite integral, there's no plus C. So it has to be one of these guys. Right? And so we see the function here is 2x cubed. Right, that's the antiderivative of that. So that looks good. So it has to be one of D, E, or F. Okay, now it can't be F because there's no minus sign, right? Remember, it's the total change. So it's F of B minus F of C. So it has to be one of these guys. Which one of these is it? D, right? Because it's B cubed minus A cubed, right? So similar kind of thing. So I believe that's a 5 up there that's been covered there. It's a similar kind of thing, right? 6x squared, what's its antiderivative? 2x cubed. Straight away, you see that this is the only possibility. Okay. And again, they try to trick you with the plus C. Oh, we have to do a bit of arithmetic in our head. Do we? Can anyone just tell the answer just by looking at the which ones can we throw away? We go 1, right? Because there's 1 there. It fits inside a rectangle of 1. So it can't be that. Can it be that? Too big. Can it be that? Negative. Okay, this is the only one it could possibly do. We didn't even have to do any math just by looking at it. Right? And of course, 1 on x squared, you know, the antiderivative is minus 1 on x. So it's equal to 1 minus a half. Yeah, it works if you want to. Okay. So the thing about the improper integrals is a little tricky, but you can handle it. And I'll see you guys tomorrow.